Hey everybody, Mr. Sellers here, 8th grade science. I was going to walk you through some motion graphs. So we have a bunch of distance time graphs. And so one of the things you're going to be asked to do is to be able to describe the motion of an object or runner using a distance time graph. So first thing I want you to notice is that this is the y-axis. This is the distance from the starting line. And then on the bottom axis, the one going side to side, which we call the x-axis, is the time in seconds. So on our experiment on Canvas for today, we're supposed to watch this video, which you're doing now, to help you interpret information about the different types of distance time graphs. So on number 1, it says make the following graph, which we have made. We're going to click the green start button, and we're going to observe what happens. So we're going to first watch the blue runner and watch what happens. And I want you to notice that the line starts at 20. So look where the blue runner is. The blue runner is at the 20-meter mark. And then the red runner is at the 0 mark. And that's the start line. So let's press play and watch what happens. So I'm going to reset that. We're going to watch the runners again. So watch the blue runner and compare it to the blue line. And we're going to do it one more time. Same thing. Watch the blue runner compared to the blue line. Now we're going to watch the red runner compared to the red line. And we're going to do that one more time. Watch the red runner compared to the red line on the graph. Yay, so we got runner. So red looks like they won. So on our questions, it says, on a distance time graph, how does a horizontal line describe the motion of the runner? So this is the motion of the runner for the horizontal line. And if we watch, what does the blue runner do? They stay still. So this means at rest or stopped if you see a line like this on a distance time graph. For the red runner, it says, how does a diagonal line describe the motion of the runner? So if you watch the red runner, we call this constant speed. So whenever the line is diagonal like this, the runner on a distance time graph is going to run at constant speed. So this horizontal line on this type of graph means that the object is stopped. And if the line is a diagonal, it means the object is moving at a constant speed, which means it's staying the same speed the whole time. So number 2, we're supposed to make 2 different graphs. And 2 points, it looks like. So we're going to do red, and then we're going to do blue. And the question is, and we need a reset. Oh, let's reset. So the green line is where they are in relation to the position. And this is also distance markers. So on number 2, we got our graph replicated, and we're going to describe the motion of the runners. So it looks like red wins. So let's play it again and compare the speed of the red runner to the blue runner. And all I'm doing right now is watching the runners. So red runner looks like running a little bit faster constant speed than the blue runner. So which runner was fastest? The red was definitely the fastest. How does the slope or steepness of a diagonal line relate to the speed of the runner? So watch that again. The steeper the line, like the red line, the faster speed they are moving. And in this case, the red runner is moving at a fast, constant speed. If you look at the blue runner is running at a slower, constant speed. So the more gradual the slope of the line, or the angle of the line, the slower the speed. And if they're really steep, like this, then they're running faster. And if they go lower, you can actually see it. Notice that the line isn't as steep, and the runner is running really, really slow. And then when the timer stops at 4, they're only at the 10-meter mark. Number 3, make the following graph on our gizmo. I'm going to get rid of the blue runner and just look at the red runner. So they're at the start line, and let's see what happens. That was interesting. So it looks like that first dot at 0 time, so that's the 0 time, that's why your stopwatch is 0. The distance marker is 40 meters. So that's where they're starting. They're starting at 40 meters. So this line is showing that they're running at a constant speed back to the 0 position, which is over here. So if you watch the red runner, that means they're running back to the starting line or to the 0 position. We'll play it one more time. So the red runner is running back to the 0 position, which is the starting line. So when the line is a diagonal like that, it means they're running at a constant speed back to the starting line. So describe the motion of the runner. They run back to the starting point. Why do they run the way they do? Well, it's because they started at the 40-meter mark and they're going to 30. They'll pass the 30-meter mark at 1 second. They'll pass, and I'll show you. So they're at the 30-meter mark at 1 second. There's the 1 second. There's the 30-meter mark. They are at the 20-meter mark at 2 seconds. There they are at the 20-meter mark. And then they go to the 10-meter mark at 3 seconds. And then they're back at the beginning. So why did the runner not slow down? Well, the runner didn't slow down because we've learned earlier that this type of line means it's constant speed. So now we got this graph. So we got 1, 2, 5 points for blue. So let's bring blue back up. I'm going to move it to 5 points. It looks like we're there. We're close. So now we're going to learn what these types of lines mean. So a lot more going on in these graphs. So let's start the runners over. So we're going to click the green start button on the timer, and then we're going to describe the motion of the blue runner, and we're going to describe the motion of the red runner. So let's watch the blue runner first. So blue runner runs at a constant speed, and then they run at a faster constant speed. I didn't make my line quite right. So we'll do that again. They run forward at a constant speed, and then once they're here, they run at a faster speed. So what they're doing is, because the line is slightly curving up, that means they're getting faster. And in physics, we call that accelerating. That's one form of acceleration. And then down here, if we watch the red runner, red runner runs at a constant speed until they get to the 2-second mark, and then, which is the 10-meter mark, and then they stay at the 10-meter mark, even though time keeps going. So once the red runner gets to 2-second to 10-meter mark, they stay and time keeps going. So they stay at that position, which is 10 meters. So motion of the blue runner ran at a constant speed forward, and then at the 2-second mark, ran faster. How would you describe the motion? Oh, that was, yeah. How would you describe the motion of the red runner? So red runner runs forward at a constant speed until they get to the 10-meter mark, and then they stopped until the end of the race. What did the red runner do from 2 to 4 seconds? So from 2 to 4 seconds, the red runner stayed stopped, because that's what that horizontal line means. And number 5, ooh, this will be fun. So let's just look at the red runner. Got there, there, and there. So based on everything you've learned so far, how would you describe the motion of this runner? So let's look and see. So from 0 to 1, and then 1 to 2, what do we think is going to happen? 2 to 3, and then 3 to 4. So they run forward, stop, run forward again, and then they run backwards. So that line means run forward, stopped, run forward, constant speed, and then when they got to the 20-meter mark, they ran backwards back to the starting line. We'll play it one more time. So that is what the distance time graph means in relation to what the red runner is doing. So hopefully you saw how to describe the motion of the runner. And then that is distance time. So just to review, this is a distance time graph. When you have a line that is a diagonal, it means they are running at constant speed. If you have a horizontal line, it means they're going to stay stopped at that particular position or distance marker. If you have a line that is starting at like that, which is at the 40-meter position, that means it's going to go back to the starting point or the 0 position. You can see that on the graph, the 0 position. And if one line is steeper than another line, it means they're going at a faster speed. Do the blue. So once again, if you have a steeper line like the red runner here, that means they're going to cover more distance in the same amount of time. And then the blue runner's not going to get as far in the same amount of time. So we watch them. Red runner is definitely running at a faster constant speed. So those are the 4 different types of graphs you need to know and be able to relate it to how an object or person moves.